All right, here's a good question that deals with angular velocity and linear velocity. So here's the formula that governs those two. V is equal to r times the angular velocity. Okay, so they say the linear speed of a point on the cylinder surface. So that's this value here. So I can write that as 124 meters per minute is equal to the radius. There's the diameter, so the radius would be 0.231, I think. 0.231 meters times by angular velocity. Okay, so if I manipulate, angular velocity is going to be equal to 124 meters per minute divided by 0.231 meters. Okay, so if I do that on my calculator, I get 124 divided by 0.231 equals. So this is equal to 536, about 0.8. The meters cancel. Angular velocity is always measured, and this unit sort of just appears in radians per given time. So there's my answer, 536.8 radians per minute. But the question says, what is the angular speed in revolutions per hour? Well, this is radians per minute. I've got to change both of those. So I can change the radians into revolutions because 1 revolution is the same as 2 pi radians. So the radians will cancel out. And then for the time, I've got to change minutes to hours. So I know 60 minutes is the same thing as 1 hour. Minutes cancel. So now if I multiply, things should work out. So 536.8 times 60 divided by, in brackets, 2, and where's my pi button? There it is. 2 pi. Go. So I'm getting 5,126 revolutions per hour. Now, you think about today's printing presses, they're probably way faster than that. But the time Gutenberg's, that's the old one, that's not a bad number for that. Okay, hopefully that helps you with that question.